Okay, so this this video will go over the solutions to Unit 2, assignment number 5. And the focus here is basically you're coming up with an exponential function given 2 points. Like, 2 points determine a line. If you're given 2 points, you can find the slope, and then you use the slope with the point, and you use your formula y minus y1 over x minus x1 equals your slope, and then cross multiply and solve for y. As with this video, we're telling you that these 2 points belong to an exponential function of the form a times b to the x. And the simplest situation is when you're given x to be 0. So that's the initial point you always want to start with, because it's going to give you a pretty quickly. So you write down f of x equals a times b to the x. When x is 0, I get b to the 0 times a, but the output is 8. B to the 0 is 1 times a is a equals 8. So now you can replace a with 8. So now you'll get, when you use this ordered pair, remember this is x, this is y. So you're replacing f of x with 15, a with 8, x with 12. And you'll get here 15 equals 8 times b to the 12th. Divide by 8, and you'll get 15 over 8 equals b to the 12th. The inverse of b to the 12th is the square root. I'm sorry, not the square root, the 12th root of 15 over 8. And we're going to take the positive because b can only be positive. So therefore, in your calculator, you'll enter in 15 divided by 8, hit the caret key, 1 divided by 12. 1 divided by 12 represents the 12th root of this, which means what number times itself 12 times gives you 15 over 8. We do need to record b to 6 decimal places, and there it is. You got the a, you got the b, there's your function. You can always try out to see if it works. If you use your calculator, just go 8 times 1.053780 caret to the 12th power, and you should get almost 15. You won't get exactly 15. You'll probably get 14.999 because of the fact this was still an approximated answer. In the part B, again, we're going to start with this ordered pair where x is 0. So when x is 0, you get b to the 0 times a, and the output is 28. So 28 equals a times b to the 0. Just substituting. This is x, this is f of x. B to the 0 is 1 times a is 28. Over here, now use your second order pair. When the output is 25, the input is 11. So 25 equals a, which we know is 28, times b to the 11th. Divide by 28, and I'll have 25 over 28 equals b to the 11th. How do you undo b to the 11th? You're going to take the 11th root of the other side. So b equals the 11th root of 25 over 28. So in your calculator, you would enter in 25 divided by 28 caret to the parentheses 1 divided by 11. To the 11th, that's going to raise it to the 11th power. And we do need 6 decimal place accuracy, so 0.989750028. And you got the a, you got the b, and I did ask you to find, using this function, find f at 9. So all you're going to do is in your calculator, in one step, type in 28 parentheses 0.9897028 caret to the 9th power. And you should get about 25.5204. Now over here, I was asking you for what value of x does this function equal 20. So I'm going to set the output equal to the output. So I'm going to set this function I have, the a, the b to the x, equal to 20. So remember, you always have 2 options. You can put this side into y1 and this side into y2 in your calculator and calculate the intersection, or you can set it to 0. So what I'll do is I'll set it to 0 this time. So I'm going to type in y equals, clear that out. I'm going to type in 28 parentheses 0.989750028, right? Caret to the x power. And delete some other stuff here, I think. My calculator doesn't want to cooperate. Delete. Delete. I think I'm okay. And then minus 20, though. So there it is right there. We have an extra set of parentheses, but it's okay. And I always do zoom 6 first to see where I'm at. And notice that I'm not seeing the intersection. I'm not seeing it cross the x-axis. So therefore, I'm going to increase my window. Let's go out to maybe 30 for the x maximum and see what I get there. So I'm getting closer for it to cross the x-axis. So we have to adjust the window again. So hit window, maybe go out to 40, graph, and now I'll see it cross the x-axis. And we know now to calculate that 0, we go second, calculate 2 for 0. The left bound is above, the right bound is below, and then on it is that, and we get 32.6589. And then part C was a little different. It's a little more tedious, but not anything harder because of the fact you don't have one of the x's being 0. So you still, you're back to this general form of this exponential function, and you're going to let x be -3, and you're going to let y be 80. So what happens is when you do that, you get a times b, the -3rd, equals 80. Never work with the negative exponent. Kick it to the denominator to make it positive. And, just kick it to the bottom and make it positive. So I'm going to cross multiply and get 80 times b cubed equals a. That's all you can do right now. Go to your second ordered pair. Let x be 3 and y be 4. So you'll get 4 equals a times b cubed. Solve for a again. So divide by b cubed, and this is what a equals. So you're actually solving an equation by a system of equations by substitution. So think, a equals this, a equals that. What are you going to do? I'm going to replace this a right here with 80 times b cubed. So I'll get 80b cubed equals 4 over b cubed. Cross multiply. So I'll get 80 times b to the 6th equals 4. Divide by 80. And I'll reduce that to 1/20th. You undo the power of 6 by the 6th root. So you got to enter in your calculator 1 divided by 20, caret 1 divided by 6. And 6 decimal place accuracy, I believe, produces, if I do the 120, well, let's do the 1 divided by 20, caret to the what power did I say? 1/6. Oh boy, that's not it. Parentheses 1 divided by 20, caret 1 divided by 6. I did get 0.609622. And then once you have B, it's easy. You just got to replace that back here to find A. So B is this. B is this value right here. So what you could do is you could do 80. On your calculator, do 80. Parentheses, this is what you found B to be. 0.6069622. Close it. Okay. So this is your 80b cubed. And you'll get 17.8854. It looks like maybe I copied down some wrong decimals. So 0.885, or did I not go here? 0.6069622. Okay, maybe I went further. And this here is 17.8854. Maybe like I'm getting 1 then, maybe, And then, again, once you find B, class, it's not hard. You just put it back in here, But you got to cube that value first and then times it by 80. You can do it in one shot like I did on my calculator there. And then this is your function. And when you let x be 0, this is 0 powers 1 times this is just that. That's as hard as they get. Not bad. It's just a little bit of algebra 1. And then here, informally without graphing, determine the end behavior on asymptotes. So the first thing you got to recognize is your base. Your base is bigger than 1. The x is positive. So when the base is bigger than 1, it's increasing. The x is positive. It stays in that direction. The a is also positive. It's going to stay. So now I have my end behavior towards infinity is infinity, and towards negative infinity, it's approaching 0 because that constant there is understood to be 0. Remember, limits towards infinity and negative infinity are answers to horizontal asymptotes. This graph is approaching the horizontal line y equals 0. That's the horizontal. And number 3, recognize b first. B is less than 1, so the graph is going to fall from left to right. The x is a positive value. The x is a positive coefficient, so it stays in that direction. The value of a is negative, so it flips it that way. So what's this function doing? Increasing and concave up. The limit towards infinity is going to approach the horizontal asymptote, which is at 3. So don't forget to put in the 3, which I didn't say that. And then you have it approaching like this. So towards infinity, it's 3. And towards negative infinity, it's going off to negative infinity. And the asymptote is y equals 3. And this function here was increasing and concave up. Number 3, you've got to know this for your test coming up, is be able to solve a trig equation using an identity. So we're going to replace sine squared with 1 minus cosine squared. And we're going to distribute and get 4 minus 4 cosine squared plus 4 cosine minus 5. This is all algebra. This is negative 4 cosine squared plus 4 cosine x, and 4 minus 5 is negative 1. Always, you don't want to factor this coefficient negative. So divide it out. It becomes 4 cosine squared. If I divide out that negative, then this gang becomes a minus right here. Because when I divide that negative out, I have negative 4 cosine squared plus 4 cosine minus 1. When I divide out that negative, I'll get a positive, negative, positive. And that changes this right here. That's how that's going to reverse FOIL. 2 cosine x minus 1 times 2 cosine x minus 1. Set this little equation equal to 0. Add 1, divide by 2, and we'll get cosine x equals a positive 1/2. So that's going to keep us in quadrant 1 and 1 and 4, right? So here the reference angle is still pi over 3. So in the first quadrant, the answer is pi over 3 plus 2k pi. In the fourth, it's going to be 5 pi over 3 plus 2k pi. Okay, so here's your answer in the first, and here's the answer in the fourth. This one we've done a lot. Sine 2x converted to 2 sine x cosine x, subtract the cosine, factor out the cosine, and cosine of x equals 0 where? Where's cosine 0? Where's the x coordinate 0? And that's at pi over 2 and 3 pi over 2. Here, make these small equations, add 1, divide by 2. Where's sine 1/2? First quadrant and second quadrant where sine is positive, it's 1 root 3 and 2, y over r. Your reference angle is pi over 6, so it's pi over 6 plus 2k pi. And in the second quadrant, it's pi minus pi over 6 again, which is 5 pi over 6 plus 2k pi. And each of these get plus 2k pi. Next, finishing up the home stretch, the table of values. So we calculate obviously, we're not multiplying to go from term to term. So that's the first question you ask yourself is, am I multiplying to go from term to term? And the answer is no. So what I do is I'm going to subtract the differences. 4 minus 0 is 4, 16 minus 4 is 12, 52 minus 16 is 36, 160 minus 52 is 108, and what is that? Was it 484 minus 160 is 324. But now before I go ahead and take another set of differences, look to see if you're multiplying by a constant. 4 times 3 is 12, 12 times 3 is 36, 36 times 3 is 108, 108 times 3 is 324. Since I'm now multiplying by a constant by a factor of 3 over consecutive equal length inputs, it's going to be exponential. So over here, I'm going to take my differences. 1 minus 4 is -3, -8 minus 1 is -9, -23 minus a -8 becomes +8, which is -15. Negative 44 minus the negative 23 becomes plus 23, which is negative 21. And negative 71 minus the negative 44 becomes negative 27. Obviously, I could see I'm not multiplying by the same number to move from term to term, so it can no longer be exponential. Now I'll take the second set of differences in which I'll get negative 6 for all of these. Since the second set of differences are the same over consecutive equal length inputs, the function's a quadratic. And your basic function, so important. The vertex value is 2, 0. There it is. Pick x is 3. 3 minus 2 is 1 times 2 is 2. So over 3 up 2. And the domains are reals. The range is from 0 to infinity with a bracket. And don't ignore this part. This is important for your SATs. Set the function equal to 0, divide by 2, and x minus 2 equals 0 when x is 2. In B, the vertex is 0, 1. If you want to rewrite it like this, that's fine. The vertex is 0, 1, plot it. Pick x is 1. The square root of 1 is 1 times a negative is negative 1 plus 1 is 0. Pick 4. The square root of 4 is 2 times negative is a negative 2 plus 1 is negative 1. This graph is flipped upside down. Why? Because of the negative in front. So therefore, my domain is from 0 to infinity. The range is from negative infinity to 1. When I set this equal to 0, I subtract 1, divide out the negative, and x is 1. That's the 0. That's where the graph should cross the x-axis. And finally, the last two, sine inverse of negative 1/2 gets the restrictions. The sign is negative, so it's down here, negative 1, 2, root 3 is a triangle. But in this quadrant, it's negative pi over 6. Remember with the inverse function, sine and tangent and cosecant are bounded between negative pi over 2 and pi over 2. Tangent inverse of 0, this is y over x. Where's y 0? Right here. Where's x 1? Right there. And here's our answer to that. That would be 0 radians.